Hi guys, good afternoon. So in the last session we discussed about ARP and types of, right? And today's task was DHCP. So tell me what do you know about DHCP? Dynamic host. This is full form. What else? One by one. Yes. Okay. Same. In interview also we'll say the same. Uses DORA process. Okay.
Also its local configurations like for domain name
Uh-huh.
and default gateway and DNS system.
Okay. Yes. Tell me something. Huh? Say it. If it's the same, still say it. Yes. Mhm. Okay. Yes. Black t-shirt. Last. Yes. Port number 67 and 68. 67. 67 for server. 68 for client. Runs on UDP. That means uses protocol number 70. Right? Okay. Now stands for dynamic host configuration protocol. Now, generally, we say that okay, DHCP is used to do what? Dynamically assign IP addresses to the client systems, right? So, not just the IP address it is assigning, it is also assigning what? Subnet mask, default gateway, DNS server, WLC address, lease time, so many things are there, right? So, what do you say? You can say it is, or how we can define DHCP stands for Dynamic Host Configuration Protocol. It is a layer 7 protocol that is used to dynamically assign IP address and other IP parameters to the client systems. Right? This is how you can define DHCP. DHCP uses UDP service, or yeah, you can say UDP service. Okay. It uses port number 67. Okay. For server and port number 68 for client. Correct? All right. Now, if we talk about DHCP, right? So DHCP is assigning IP addresses. So overall use of DHCP is to assign IP address. Other parameters like your, subnet mask, your default gateway, your DNS server, all those things DHCP assigns with the help of options. There are certain DHCP options. So with the help of options, your DHCP is assigning all these things. Okay. And there are rules, right? There are few rules. What are the rules? Number one is the DHCP server. Now, who is the DHCP server? Let's say if I ask you what is the DHCP server, how will you define it? How you are going to define a DHCP server? A database. Hmm. Who assigns? Who provides DHCP service? Hmm? Who is going to provide the DHCP service? Don't say DHCP server. It's a node, right? A node that is responsible for providing the DHCP service, or a node that is responsible for assigning IP addresses and other IP parameters dynamically to the client systems. That is a DHCP server. We cannot directly say, okay, who assigns IP address or who provides DHCP service. That is not a relevant answer. Clear? So you can say like a node that is responsible for providing the DHCP, or you can say DHCP service, or you can say, okay, let me write both of them. Providing the DHCP service to the client systems. Okay, this is one way to say. Another way, you can say a node that is responsible for assigning IP address and other IP parameters dynamically to the client systems. Right? That is the DHCP server. Now, who is the DHCP client? Who is the DHCP client? And node that is using this service. Okay. And node that uses the DHCP service from the server. That is a client. Another one. Relay agent. Now, what is the DHCP relay agent? Forwarding packets to the DHCP server. Okay. Which is in different network. How will you define a relay agent? Because when you studied about the concept, you studied that, okay, relay agent is used when your DHCP server is not present in the same network. When your DHCP server is present in the different network, that time you use relay agent. But what is relay agent? Who works for the DHCP server? Nice. On behalf, is it proxy? Hmm? So a node that facilitates IP address assignment between the DHCP server, or you can say a node that facilitates DHCP communication between the DHCP server and DHCP client when they are not present in the same network. This is responsible for exchange of DHCP messages between different networks. A relay agent is responsible for exchange of DHCP messages between different networks. That is the responsibility of DHCP relay agent. Because when your DHCP server is not present in the same network, then DHCP discover messages, right? Offer messages, all your acknowledgement, request, these messages, they will not travel from one network to another network. Why? Because these are broadcast messages, and router never forwards a broadcast message from one interface to another interface, right? So that is the reason we require what? Relay agent. Clear? Can I use a switch as a relay agent? Hmm? Yes or no? What about a layer 3 switch? Have you tried? Then how can you say yes? Hmm? How can you say yes then? Hmm? So can you use or not? Yes? No? You can use it. Okay. You can use a layer 3 switch also as a relay agent. Your multi-layer switch, you can use it as a relay. It works very fine. Okay. So relay agent, a node that is responsible for facilitating the IP address assignment and for exchange of DHCP messages between the DHCP server and DHCP client when they are not present on the same network. Okay. These are the rules. DHCP server, DHCP client, and DHCP relay. Clear? Now, you say that, okay, your IP address assignment process. Okay. The DHCP IP address assignment undergoes how many messages? Four. Four messages. For a successful IP address assignment, four messages are exchanged, and those four messages are discover,
Offer,
offer,
request,
request.
acknowledgement.
Yeah. Now my question is, these messages are broadcast or unicast or multicast? But it depends on the client. Looks like you have watched the video. Okay. Broadcast, unicast, or multicast? So far, you have seen only broadcast, right? But it depends on the client. Depends on the operating system. Clear? So, in general, these are broadcast only, but It varies from client to client. Yeah. So I'll show you for three different operating systems. Okay. We will see this IP address assignment process for three different operating systems. Okay. Number one, we are going to see is for Windows OS. Number two, we will see is for Cisco iOS. Number three, we will see is for Linux operating system. These three OS we are going to check. Okay. Now, let's go and see. So where do you configure the DHCP server? A DHCP server generally so far you have configured it in the router only, not firewall too. You have configured, but you can configure. Okay, you can configure it in your edge device, which is a router or a firewall, or else you can also configure it in a server. There are dedicated server machines. Okay, like in your packet tracer also you have a server. In your packet tracer also you have a server. There also you can configure DHCP. But in real scenarios, either you will be using a Windows server machine or a Linux server machine. Okay. All right. Who tried this URL? Anybody? No. Okay. So this is going to be a lab, and I'm going to wipe out all the nodes. So this is a router only. Okay. A router only I will be configuring as a DHCP server. Okay. Only the icon is different, but you can see this is a router. Okay. So this is a router here. Here, this is again a router which is going to work as a gateway, because single lab we will see practical for your relay agent also. Okay. And here I have a VPC. I have a client machine. Basically, this is Windows. You can see here, this is a Windows 7 machine. Then I have a Linux machine here. Okay. And this is again a router. Okay. So Cisco iOS, Linux, Windows, and this VPC. So this is also kind of based on Linux only. Okay. All right. So let's start all the nodes. So this side we are using the network 192.168.10, and on the client side we are using 10.110/24. That means the DHCP pool that I'll be configuring, that pool will be having what? 10.110/24 network. Gateway will be 10.111. Okay. So basically, like the DHCP pool we are going to configure is going to have the network configuration as 10.110/24. mask, I'll say subnet mask in short SM, which is okay. /24 already explains it. So let's say gateway will configure 10.1.1. DNS we can configure, which is, let's say, for example, .8.8. This will be our network configuration. Now let's take access of the DHCP server. And also the gateway. Here we are going to say no. Okay, who will tell me how to configure a DHCP server? Mhm. Network ID and subnet mask. Mhm. Then we can not default DNS, we can give it DNS. Okay. So first of all, let's change the host name, which is DHCP servers. Then let's configure the interface. Interface gig 0/0. IP address 192.168.10.100. Done. Then no shutdown. Okay, how many IP addresses I can assign on this interface? On one interface of a router, how many IP addresses I can assign? 65,000.
Sub interface you can create one.
No, without sub interface, physical interface I'm talking. Sure. How many IP addresses I can assign? One. Are you sure? What if I can show you more? Okay. First, let me clear this out. If I check to show IP interface brief, I can see the IP address, right? I can see the IP address. Do show running interface gig 0/0. I can see one IP address. Do show interface gig 0/1. Here also I can see (0/0). Just one. So running interface. So you can see here, I have only one IP address. Everywhere one IP address only. Okay. Now, interface gig 0/0, right? IP address. Let's say if I say 172.16.10.1 255.255.255.0. If I hit enter, what will happen? It will overwrite. Everybody agrees? Let's see. do show IP interface brief overridden. Do show interface running interface link 0/0 overridden. Okay, overridden, right? Okay. Again, if I will say, let's say my old IP address is this one. Again, overridden. Agree? Now, what I'll do is, if I use the word secondary, now let's see. Show IP interface brief. What happened? Still one. Okay. How many? Two. Right? Here it's showing one. So let me say show show IP interface. One, two. So that means how many addresses I can assign? Hmm? How many? 3 to 4. How? Secondary, tertiary, like that? Okay. Let's see if we have such kind of word. Only one secondary word I have. So that means how many I can assign? 2. Okay. So what will happen if I say, let's say, for example, 20.1, or let's make it 17.16.20.1. Now, it should overwrite. Let's see. Do show IP interface B. Here only one it will show. Do show run interface G0/0. What happened? Hmm? Then do show IP interface G0/0. Now what? How many? 3. So if again I'll change the IP address, maybe let's say 19.16.1.1. So what will happen? Again a new IP address. So multiple IP addresses can be assigned. What is the benefit? Right? Okay, in Windows, how many IP addresses you can assign on one NIC? 4, 5. 4 to 4, 5. 4, 5. One, two, three, 4, 5, 6, 7. I can assign more also. So any NIC, you can assign more than one IP addresses. You can assign a number of IP addresses. Why? Because if you want that, okay, my device should communicate through the same interface but with multiple networks. Right? If you want that, okay, my device should communicate with multiple networks, I can assign number of IP addresses. Clear? Now clear why? Okay. How many people clear?
Yes, sir.
Okay. Let's say now if I check, I have some configuration, right, on my interface. Now I want to remove all this configuration. What should I do? No. So how many times I have to give the no command? 4 times, right? I don't want to give 4 times. Because right now I have only 4, but maybe I have done so much of configuration, 10, 15 lines of configuration, 100 lines of configuration.
Default interface.
We can set the interface to its default characteristics. How? You can say default interface give 0/0. You see? Set to default configuration. Right? So now check back to its default configuration. Is that clear? But these commands you have to be careful while using in the production environments. Otherwise, you might end up creating a disaster for the company. Right? Okay. So you can use default interface and interface name to set the interface to its default configuration. Clear? Now let's set the IP addresses that we want to set here, which is 10.100. So interface gig 0/0 IP address 192.168 10.100 255.255.255.0 and then no shutdown. Then now we need to configure the DHCP pool, right? So I'll say, okay, first we will not configure here because initially we want that, okay, the IP should be coming from gateway only. Okay. Later on we'll change. So on the gateway, we have to do the configuration. Enable configuration terminal. Interface, first of all, host name. Host name is gateway. Interface gig 0/0. What will be the IP address? 10.1.1.1 255.255.255.0. No shutdown. Interface gig 0/1. See, sometimes what happens when I'm typing the command and then a log pops in and my command gets broken. If I don't want this thing, what can I do?
Logging synchronous.
We can go with the logging synchronous command, right? So what we can do, we can say line console 0 and we can say logging synchronous. Now this command will do what? Every time there is a log, automatically your command will come into the next line. Your command will not break down. Okay. Now see here. If I say interface gig 0/, let's say 1, then I'll say no shutdown. And let's say now I'm typing IP address. IP address. Okay. So you see automatically my command came into the next line. My command did not get broken down. Like I did not continue typing here. Right? That creates a lot of problem when we are doing the beginner, as a beginner, we are doing the configuration because we don't know what part of command we typed already and now what's going on. Okay, so there it will be helpful. Now IP address, and on the Z0/1, we have the IP address 10.1. So 192.168 10.1 255.255.255.0 and no shutdown we have already given. Now we need to configure a DHCP pool, right? So we configure it as IP DHCP pool, and we have to give a name. So let's say we will give it a name as CCNP, then network, network ID, which is 10.1.1.0, subnet mask, then default router, and gateway address. Then I can say DNS server and 8.8.8.8. What if I give the command again? 4.4.4.4. Let's check to show run section DHCP. Will override. Okay. So as of now, let's go with the main topic. So this is our DHCP configuration as of now. But you can see the IP 10.1.1.1 I have already assigned. I don't want my DHCP to assign this IP address. What should I do? We should exclude this address. Okay. So how do I exclude? IP DHCP, excluded address, source IP, starting IP. Okay, so let's say I want to reserve the IP addresses from here, but I want to reserve only one. What to do? Same. Particular IP given, right? If I give question mark, my command is still okay. It says unrecognized command. Why? Submit mask. Why it says unrecognized command? But still, why it is saying me that this command is unrecognized? It should tell me that, right? Exactly. So it's a global configuration mode command. And right now we are in the DHCP configuration mode. Understood? Right now we are in the DHCP configuration mode, but this command is for global configuration mode. If you type the command will work. If you type the command is going to work. And you will automatically jump to the global configuration mode. Let's say if I say from 10.1.1.1 to 10.1.1.10. This is the range I want to reserve. So command will work. And from DHCP configuration, I will go to the global configuration. Why? Because this command is for global configuration only. But there, when I use the question mark, it was telling me unrecognized. Why? Because the command was not relevant to that particular mode. But the same thing if I do here. Now, if I give question mark in the correct mode, now it's telling me that it is asking me about higher IP address. Basically, the ending IP address. That from where to where you are trying to reserve. So you must be understanding these things, because when you give the question mark and you're getting an output, you must understand that what is the reason of this thing. Clear? Okay. So let's say we have reserved the addresses from 10.1.1.1 to 10.1.1.10. Right? Okay. Now we will start. So you can use the same IP address starting and ending. Right? You can use the same IP, or else simply you can say exclude that address, this one. That's it. Either starting and ending same IP, or else just this much on. Totally fine. Okay. All right. Okay. So you can see. Okay. 2 times we gave the comment, right? 1 time this one, and second one, this one. So that's why both comments it has taken. This is clear. Now let's say I want to check that, okay, what is the configuration of my DHCP pool? Okay, what is the status? We can say show IP DHCP pool and the name of the pool, which is CCMP. So it will tell me that, okay, the total addresses that we can assign is 254. And how many addresses has been already leased? 3 addresses already leased. But I did not go to any client and request any IP address. Then why? Hmm? Default gateway
You
excluded IP address. That is different. Here it is telling me current index is 5. That means IP number 2, 3, and 4 already assigned. Clear? Let's check. Let's go to the clients and we will check. This is the VPC. And if I say show IP, is there any IP address? No. That means this guy hasn't taken an IP address. What about Windows? So Windows NIC by default is set for automatically obtaining IP address. That is the reason that Windows has taken the IP address. Okay, you see here automatically giving her network. So if you see this network, that means IP address is there and communication with the gateway is successful. So if I check IP config, you can see Windows has automatically taken the address 10.1.1.3. Okay. But what I want to do is, and you can see it is coming up from the DHCP server 10.1.1.1. Okay. I'll just go and change it. I'll say use the following IP address. And let's say I'll just give a random address. Okay, as of now, I have given a random address in the Windows. Linux, so this Linux machine, this is Kali Linux machine. And this is also by default, the adapter is set to automatic. Okay. This operating system is majorly used for cyber security and hacking. You can see receive the IP address 10.1.1.4. Okay. So here also, let me go and shut down the interface. Okay, here also we have disconnected, but also I need to change. Because see, one time they have taken the IP address, then what will happen? That they will not send the discover message. They will only send request. Charlie top IPv4 manual. Just any random IP address I'm giving here. Okay, so now this is 1.1.1. Okay, router. You can see this router here. Okay. And router interfaces are by default down, right? Router interfaces are by default down, and you can see it is still asking yes or no to me. So is it possible for this router to get an IP address? No. Then who is the third person getting the IP here? This guy haven't received an IP address. These two people received, and router interfaces are by default down. because I haven't configured the router. Then who's taking the third IP address? So it's layer 2 device. 1.1 static IP. Then who is taking the IP address? Hmm? No idea. It is the router only. When a router is powered on, the interfaces are up. When the router is powered on, the interfaces are up. And that time, the router will send discover messages. You will see. Let me capture the interface. Okay. So as of now, it has already taken the IP addresses, but you can see here. What kind of messages? Isn't sending the discover messages? Sending, right? This is the router sending the discover messages. And right now you see these discover messages regularly, continuously these discover messages are coming. And our DHCP server 10.1.1.1 is sending what? After. Correct? Now see. As soon as I'll say no here, right now these blue messages, these are all DHCP messages. As soon as I'll say no here, you will see that, okay, now after 59 or 60, you will see now DHCP messages will stop. Now there is no DHCP message. Why? Because this time the router has actually started and loaded the pre-config, and in the pre-config, every interface has a shutdown command. Now you don't see any discover message. Clear? Online people clear?
Yes, sir.
So many things are there, right? Okay. Well, that's it. But the thing is, now our DHCP, I mean our gateway, if we take a look, two addresses are still assigned. I want to reset this thing. I want to reset this thing. So how can I reset? Hmm? No idea. No IPDHCP will remove the pool itself. Okay. See, we can look at, show IP DHCP binding. So we can see that, okay, 10112 is assigned to this guy and 10114 is assigned to this guy. Automatic assignment was there, right? So let's clear it out. Clear IP DHCP binding. Start. Let's take a look. Show IP DHCP binding. Right? Assignment is gone. DHCP, Google, CCNP. So least address is 0. Okay, and current index it says 10.1.1.5. Okay. Let's say clear IP DHCP pool CCNP. Okay, and let's say binding start. This is done. Remembered binding start. Anything else? Submit. Start. Let's see. Show IP DHCP to CCNP. Okay. You see, still it is coming like this one. So we can reset the tool by removing and adding it. Okay. But although leased addresses are already gone, and we have reserved the address 1 to 10 already. Okay. So next address will be assigned as 11. Okay. Okay. Now what I want to see is like about the DHCP messages, whether they are unicast or broadcast. Correct. So first we will see for this one, VPC. Okay, so what I'll do is I'll capture the interface Z0 by 3. I'll capture the interface Z0 by 3 of the switch. Z0 by 3. No DHCP messages as of now. Okay, and let's filter it for DHCP messages only so that we don't have any extra messages. Right? Now, I'll go to the VPC. This is my VPC. Doesn't have an IP address as of now. Let's verify again. Show IP. Right, nothing. Then we can say IP DHCP. Okay. Data process complete. You can see 2 times discover message, then offer request acknowledgement. This is complete. Let's take a look here. 2 times discover, offer request and acknowledgement. So here I can see that my discover message that was going from my client to a broadcast address. This was a broadcast DHCP discover message. Then my offer message came from DHCP server to a specific IP. That means, is it a broadcast or unicast? It's a unicast. Got it? So this is a Linux based system. That's why this is a unicast. This is a Linux based system. That's why it's a unicast. Then again, request message is a broadcast and acknowledgement message is a unicast. This is clear. Okay. And let's also take a look for up. Okay. So you can see here, once the IP address was received, also one GRP was generated to check the duplication. Okay. Okay. Now, so about VPC, it is clear. In VPC, offer and server side messages. Server side messages will be unicast. Okay. See here again. In a Linux system, your server side messages are unicast. Okay. Client side messages are broadcast. And you can take a look. Let's say this is the discover message sent by the client to the server, right? So client uses port number 68 and server uses port number 67. Yeah. And protocol is user datagram protocol, UD. Clear? Okay. Server side messages. Yeah. Okay. Now let's take a look at Windows system. Okay. This is for VPC. VPC, DHCP, packet capture. Okay. And this is for the VPC. Next is we are going to take a look at Windows. Okay. Now, let me close this. This time we will capture interface Z0 by 1 of the switch. Capture Z0 by 1. Again, we will filter DHCP. Windows 7. This is our Windows. Okay. Now, here I'll go and set the IP address to automatic. Close. Discover offer. Now you'll see request and acknowledgement also. Wait for it. See here, discover offer request and acknowledgement. And if you take a look here, right? This is the DHCP discover message, broadcast, offer message, broadcast, request message, broadcast, acknowledgement also. So in case of Windows, all 4 messages are broadcast. Okay. Let me take a screenshot. In case of Windows, all 4 are broadcast. Okay. Clear? This is I'll come to that. Out of 8 messages, we have inform also. Right now, we are discussing about 4 only. Next 4 also we'll discuss. This is clear. Next one is Linux operating system, which is Kali Linux. Okay. Okay. Now let's take a look at Linux. So this is VPC. VPC is also based on Linux only. Let's close this one. So this time I'll capture Z0 by 2 interface. And let's filter for DHCP. I'll go to the Linux. And here, let's set it to automatic again. Apply. Power it off. Discover, offer, request, and acknowledgement. You can see discover is broadcast, offer is unicast, broadcast, then unicast. So in a Linux system, server side messages are unicast. Okay. This is for Kali Linux. And last one is Cisco iOS. Cisco iOS DHCP packet capture. So this time I'll capture the interface Z1 by 0. Okay. Now this is the interface I'll capture, and again I'll say DHCP. And this is our router. Now this router is going to work as a DHCP client. Okay, that means I need to take IP address on this router from the DHCP. Correct? So I'll say interface, and I believe interface is gig 0/0. Yes. How do I take IP address from DHCP? Yesterday we used this command. IP address DHCP. And then we will say no share. Let's see. Discover, offer, request, and acknowledgement. And even in Cisco, you can see all 4 messages are broadcast. Clear? Now this thing is clear. So simple statement would be, if it is a Linux system, server side messages are unicast. Rest all broadcast. Okay, so don't always say directly broadcast. You can say it depends on the operating system. Okay, in a Linux system, server side messages are unicast. Clear? Okay. Now let's come to the messages. So first message, overall we have how many messages? 8 messages. Okay, let me open that document. Usually I share this document in the interview prep. Okay, about DHCP. So introduction to DHCP, it's a network protocol that dynamically assigns the IP address and other network configuration parameters to the devices on a network. Okay, and what is the purpose? So it automate and simplify the IP allocation process. Why? Because if a large network is there and you have to manually assign all the IP addresses, bit of a complex task, right? Then we have DHCP server, client, and relay agent. Server is responsible for assigning IP address and network configuration. Client will be requesting or using the DHCP service, and DHCP relay agent will forward the DHCP messages between client and server when they are in the different subnets. Messages. So first of all, discover message. What is the discover message? Used to discover the DHCP server. Okay, whether or not a DHCP server is present in the network. So client is trying to check whether or not a DHCP server or more than one DHCP servers are present in the network or not. Okay, this message is a broadcast. Okay, then the response to this message is the DHCP offer. Now the DHCP offer message. So if a server receives a DHCP discover message, server is going to reply the DHCP discover with a DHCP offer message. And in the offer message, server is going to provide information about the next free IP address available. The server will say that, okay, this is the IP address I can provide you, and along with the IP address, these are the parameters I can assign you. Like if you take a look here, right? So this is the DHCP discover message. And if you open the DHCP discover, there is not much of an information. The client will just say that, okay, I'm looking for a DHCP server. Okay. And these are the information the client is going to send in the DHCP discover message. Like, what is the message type? So the message type is DHCP discover message. And how this DHCP discover message type is given? With the option number 53. See here. Option 53 is for what? DHCP masses type. Okay. Then after maximum DHCP masses size. That okay, what will be the maximum size of the DHCP server? 1200 bytes. Okay. Then client identifier. Client will send its own MAC address also. Right? So client is giving its own information that okay, this is me. I am a make of Cisco. This is my address and this is my interface. Okay. Other than that, the client will also try to give the name of the device, that is host name. That is for option number 12. Okay, then parameter request list. Now, what is parameter request list? That means client is telling the server that okay, if a DHCP server is present, I'm looking for all these parameters. So what kind of parameters it is looking for? Subnet mask, DNS, domain name, NetBIOS, router. That means default gateway. If there is any static route, TFTP server is there, vendor specific information is there. All these things the client is willing to receive from the DHCP server. Okay, so these are all the information the client gives to the server. Then after vendor class identifier, and then option 255 defines that okay, this is the end of DHCP masses. Is that clear? Now in the DHCP offer, the server will give the information that okay, this is the next free IP address available to me. I can provide you with this IP address 10.1.1.40. My server says, who is my server? 10.1.1.1. The server says that okay, I can give you this IP address. Along with the IP address, see here. This is the message type. This is the DHCP server identifier that okay, this is me who is assigning you IP address. This is my IP address. Okay. Then we have lease time. See here, lease time by default 1 day, but this also varies from OS to OS. This also varies from OS to OS. If you are using a TP-Link, router, default lease time is 2 hours. If you are using a TP-Link, default lease time is 2 hours. If you are using a home network, like generally we use our home routers and all, 1 day. Okay, default is 1 day. And if you have configured a Windows server as a DHCP server, default lease time is 8 days. Default lease time is 8 days. Okay, so once in a week you will get a new IP address, or your IP address will be renewed. Then we have renewal time, that okay, after how much time the client has to renew the IP address? 12 hours. Okay. Then what is the subnet mask? This is the subnet mask. Because client was asking about subnet mask, right? This is the subnet mask I can assign you. This is the default gateway. Then this is the DNS server. Is that clear? And then option 255 defines the end of DHCP masses. Right? Okay. So this is how, with the help of options, IP address it will assign. Rest of all the IP parameters it will assign with the help of options. Then after request, so client will send a request message saying that okay, I am ready to accept this IP address. Okay. So this is a message type is request. Okay. Then server identifier. This is my server. Requested IP address. What is the IP address I'm requesting? And then I'm also giving you information that okay, this is my host name. Okay, this is my MAC address. Okay. Then again, these are the parameters I requested. Same information again. And then again, end of DHCP masses. And then server will send an acknowledgement about that. Okay, now you can use the IP addresses. Okay. This is clear? Yes or no?
Yes.
Okay. So 4 messages are clear. Discover, offer, request, and acknowledgement. So offer is what? It is sent by the DHCP server in response to the DHCP discover message, and it contains IP address, lease, duration, subnet mask, and other configuration parameters. Then once the client receives the offer, client will perform a quick duplication check using a ZR, right? Then once client is satisfied that okay, there is no duplication of the IP address, what client will do? Client will send a request message and will say that okay, you can provide me this IP address. I'm ready to accept this IP address. Okay. Then what it contains? It contains the selected DHCP server as well as the requested IP address information. Okay. Then the DHCP server sends a acknowledgement. Okay. So server will send an acknowledgement saying that okay, now you can use this IP address. And what server will do? Server will bind the client MAC address with the assigned IP address and mention this information in the DHCP binding table. In the DHCP binding table. These are the 4 messages you have studied. Message number 5, DHCP decline message. DHCP decline message. So what is the DHCP decline message? Let's say, for example, client found that okay, the IP address the server is trying to assign me already exists. The IP address that my client server is trying to assign me. Let's say the server was trying to assign me here, in this case, IP address 10.1.1.14. So once client receives an offer, client will try to check it, that is there any duplication or not. If client finds that okay, the IP address is conflicting, already somebody is using this IP address, client will send the decline message that okay, I will not accept this IP address. This is already present in the network. This is where client will send what? DHCP decline message. Okay. Now let's try to practically see this thing. Okay, we'll try to create this scenario. Close this. Okay, did I close the... All right. Take a look. Let's see. This is the Windows PC. Okay. And here again, I'll give a static IP. Static. I'll give a random static IP. Let's say 1.1.1.1. Now, I'm going to go and capture this Z0/3. Now, creating these scenarios will be a bit tricky. Okay. And I'll just go and filter DHCP messages for Windows. Then what I'll do is I'll go and assign this IP manually to the router. But I know that when I'll assign the IP manually to the router, what will happen? This guy will generate a GR to inform everybody. So I want that okay, that GR should not reach anybody here. So I'll shut down this interface. Okay. So on the switch, I will shut down G1/0. Interface Z1/0 and shut down. Done. Now I'll go on the router and I'll manually assign that IP address. So let's see what DHCP server will assign next. To IP DHCP to CCNP. Next IP address it is willing to assign is 15, right? So I'll assign this IP address here. Interface 80/0 IP address 10.1.1.15. Done. So this guy will generate a GR. Do show IP. IP address is assigned. All good. Let's wait for a while. Then we will request the IP address. Okay. So hopefully the GRP is generated and everything. Now let's go and shut down this G1/0 interface. Interface Z1/0 and no shutdown. And let's go on the Windows PC and set the IP address to automatic. So we should be able to see some other IP address it has assigned. Assign 12. Okay. Let's try one more time. Okay, in the binding table, the entry is there, so I have to clear that entry also. In the DHCP binding table. Now let's try again. Now what IP? Again 12 one they assigned. Okay. So let's do one thing. Shut down the port and assign IP 12. Like I said, creating these scenarios will be a bit tricky because these are very rare conditions. Yeah. Again, let's say no shutdown here on the switch. Minimize clear properties, automatic. Discover offer request. Okay, that interface then just a moment. 50 seconds of the switch HTTP. Interface range V0/0. Z1/0. Spanning tree, port first. Now, interface Z1/0. Shut down. Let's try one more time. IP here. So, properties. Let me close this and I'll just start the capture again. And there is some Z0/1 interface. So now I'll just go and no shut down the interface. No shutdown and properties. Discover, maybe now you can see. DHCP decline process. Why? Because the client will say that, okay, this IP address already exists. But client IP address already exists. So see here, the client sent a DHCP discover message, server sent a offer message. In the offer, server was saying that, okay, I am willing to assign you 10.11.12. And we already statically assigned it in the router. So client tried to check duplication for this. And when client checked the duplication, client found out that, okay, this IP address already exists. Okay. So client did not accept the IP address. And after that, you can see there is a completely new DORA process, right? And this time the server offered 15 IP address. Clear? Okay. So decline message is clear. Okay. Release message. Now, release message is when client voluntarily releases the allocated IP address before the lease duration expires. That means the client is telling, let's say you shut down the PC. So before shutdown, the client will send a release message to inform the server that, okay, now I'm not using this IP address. Okay. So let's try that thing also. I'll try to shut down this Windows PC. Or let me try to disable it. If it is sending a DHCP, no. Then we'll shut down it. Okay. So let me try to shut down this PC. If I try. Now I'm shutting down this PC. So I should see a release message. Okay, it's already down, but there is no release. Should send like this. Okay. We need to restart the capture once. 0 by 1. The link was down, that's why we didn't get any. Okay, you can see the client has already received the IP address. Now what I'll do is okay, right now this guy is already having the IP address. You can see IP config. Okay. Let me try to shut down again. Then we have to do it using the command. First, see, one time that PC is already taken, so every time it will not do the entire DORA process. It will directly send a request message telling that, okay, this is the IP address and I want this IP address. Okay. That is why, you know, every time you see, you have the same IP address in the PC. Okay, so now we will use the command. Okay. So first of all, if I check, I can see I have the IP address. So if I try to release this IP address, I can say IP config / release. That means client is releasing the IP address, and you can see the DHCP release message. Okay. So this is how the release message. That means your lease time did not expire. You are manually or voluntarily releasing the IP address, telling the DHCP server that I'm not using this IP address right now. Okay. And then if you want, you can renew also. Okay. So when you renew, entire new DORA process will start. Clear? Okay. So release message is clear. When we are manually releasing the IP address. Okay. One is your IP address has to be renewed whenever your lease time expires. Before your lease expires, your system will try to renew. Okay. And another way is you manually release the IP address. So when you manually release, your client will send this message. Clear?
Yes.
We have negative acknowledgement. Now, what is this negative acknowledgement? Negative acknowledgement means whatever the IP address the client is requesting. Let's say as of now, if you take a look here, this Windows PC, whenever it is sending a request message, okay, whenever it is sending a request message, it is requesting what IP address? 15. And what if the DHCP server assigned the 15 IP address to somebody else? The DHCP server does not have that IP address free. The DHCP server does not have that IP address available. So what DHCP server will say whenever the client will send a request that, okay, I want this IP address, server will say, I don't have this IP address. So that means instead of acknowledgement, server will send a negative acknowledgement. Like initially when I restarted this PC, my PC sent a request and server was having that IP address free. So server said, okay, you can use it. But if the IP is not available to the server, server will send a negative acknowledgement. Okay. Now to create this scenario, what I'll do is I'll just go and disable the adapter of this Windows PC. Okay. This adapter, I'll disable it. Let's close this one and restart the capture here. To make it easy, we can okay. For this one, before disabling the adapter, what I'll do is enable this. And I'll manually assign the IP address. So I have manually assigned the IP address here right now. Now what I'll do is I'll just go and this Kali Linux site one. Okay, here also adapter, I will power it off. And IP address I will set to manual. Okay. And on the router, we had already manually assigned the IP address here. Right. And here, I'll clear the IP. Okay. And this DHCP pool, I will reset. Okay. So I'll say no IP DHCP pool, CCNP, IP DHCP pool, CCNP. Then I will say network, same 10.1.1.0. Default router. DNS server. Okay. IP DHCP. Excluded address. And 111. Sorry. Space will be there. Okay, done. Now, first of all, I will take IP address on this Windows PC. So it should take 11 IP address, right? Let's see. It has taken 15. Okay, let's say it has taken 15 IP address. Not a problem. Okay, the IP address that this PC has taken is 15. Now, what I'll do is I'll just go and disable this adapter so that this PC will remember that, okay, I have taken 15 IP address. Okay. And now I'll edit this again. Again, I'll remove it once. And this time we will reserve from 11 to 14. Okay. CCNP. Network. Default router. DNS. And we will reserve to 14. Done. Now I'll go to the VPC and I'll say IP DHCP. So it should take 15 IP address right now. Taken. The 15 IP address is already assigned by the DHCP server. Now, let's go and capture the Z0 by 1 interface and filter it for DHCP. Okay. And this Windows PC will directly request for IP address 15. It will send a request. And you see here what we have. We have a negative acknowledgement, right? So in the request message, the client directly requested about the IP address what? It was saying my requested IP address is 15. Server says, no, I don't have this IP address. Message type is negative acknowledgement. And then after, again, client requested the same 15 IP address. Server again said, I don't have this IP address. And then a new DORA process started. Yeah. Yes or no? This is your negative acknowledgement. Then we have DHCP inform message. Last message. So what is the DHCP inform message? DHCP inform message is like, client is requesting so many parameters. In the request message, client is requesting so many parameters. Even in the discover message, you can take a look here. Let's say this is the request message. So when parameter request list you open, the client is requesting so many parameters here. But we didn't configure, right? We only configured subnet mask, then default gateway and DNS. These three things only we configured. So server will provide only these three things. Remaining things server is not able to provide. And to request the remaining parameters, right? To request the remaining parameters, the client is sending what? Inform message. In the inform message, client is just telling that, okay, I need these things. You didn't provide me everything. Again, server says, okay, I have provided whatever I have. right? Whatever I have information, I have provided you, but client will again say, no, I need these things. This is your inform. That means other than IP parameters, requesting more parameters. That is your inform. Acknowledgement server says that, okay, I have given whatever the parameters I have. Server can only provide whatever the information server has. Something that the server doesn't have, how can you provide? Right? So that is the case. वो मांगता ही रहेगा. Okay. So this is how your DHCP and all 8 messages of DHCP are there. You can see regularly inform, acknowledgement, inform, acknowledgement, inform, acknowledgement. It will keep on requesting, server will say, I don't have. Okay. Clear? So this is your entire DHCP protocol. The DORA process, lease management. Important these options. Okay. So make sure to go through. These are some of the common options you can note down. Okay. Or else I'll share this document in your drive itself. Okay. But make sure to remember some of the common options, like for subnet mask, option number 1, message type 53. Okay. Then WLC address. Okay. DHCP relay agent, option number 82. Okay. So like that. Because sometimes interviewer might directly ask you that, okay, explain the option number 82. What is the use of option number 82 in the DHCP? Because you have studied relay agent concept. You know relay agent. But instead of directly asking relay agent, the interviewer will ask like this, explain option number 82 in the DHCP. Okay. So make sure some of the common things like, lease time, renewal time, your relay agent, subnet mask, and then, your default gateway. So if you take a look for your default gateway, option number 3 is there. DNS server, option number 6 is there. Option number 255, end of DHCP message. Okay. So these few things you must remember. Yeah. So this is your DHCP. I think enough about DHCP. In your CCNA, what did you say? Okay. Online people, any doubt?
Nothing.
So DHCP is clear now? Okay. So then tomorrow onwards, we will start the basics of routing. Okay. We'll go with the first of all relay agent. We have to see. Still didn't see. So relay agent we will see. Then we will go with the basics of routing. And then we will start with our static routing. Okay. All right. So this is it for the day, guys. Anyone who is attending today for the first time?